For most of human history, we were silent. Without language, there were no warnings for predators beyond a sudden cry. There were no complex plans for a hunt. There was no way to pass a lifetime of knowledge from one generation to the next. Most people assume language is as old as humanity itself. The truth is, for hundreds of thousands of years, our ancestors existed in a world without words. The question of how we went from a creature that could not speak to a species that built civilizations on shared stories is one of the deepest mysteries in science. Let's start with the problem. Unlike bones, tools, or cave paintings, language leaves no physical trace. You cannot excavate a fossil and find a sentence. You cannot carbon date a conversation. Language is made of air, and air does not preserve across geologic time. So scientists studying the origin of speech are forensic linguists, piecing together an ancient puzzle from the fragments they can find: skull shapes, hyoid bones, genetic mutations, and cave article. The first thing to clarify is what language actually is. Before humans had true language, we had communication. Animals communicate. Bees perform a waggle dance to tell their hive mates where to find good flowers. Dolphins have signature whistles that function like names. Chimpanzees in the wild have a system of calls and gestures that convey basic information. So the question isn't when life began to communicate. The question is, when communication became language, when it crossed the line from signal to symbol. There is a vast fundamental difference between the two. A signal is direct. It means one thing. A dog growls because it feels threatened. The growl is the threat. But a symbol is abstract. The word danger is just an arrangement of sounds that represents the concept of danger by collective agreement. It doesn't sound like danger. It doesn't look like danger. We all simply agreed at some point that these particular vibrations in the air would carry that specific meaning. Every word you have ever spoken is a social hallucination that billions of people happen to share. This leap, from signal to symbol, from direct reaction to abstract meaning, was the cognitive revolution that changed everything. Scientists disagree on when exactly this happened. There are two major camps. Camp 1 says language developed gradually over hundreds of thousands of years, slowly complexifying from simple calls into full grammar. This is the continuity hypothesis, and its proponents point to our evolutionary relatives, chimpanzees, bonobos, gorillas, who already show rudimentary symbolic thought. They can learn signs. They can combine symbols in novel ways. They appear to understand that things have names. Perhaps language is just the endpoint of a very long road that started far back in our ancestry. Camp 2 says something else entirely. They say there was a moment, a specific leap, probably somewhere between 100,000 and 50,000 years ago, when something clicked in the human brain. A mutation, or a threshold of brain complexity, that suddenly unlocked full recursive syntax, the ability to embed ideas inside other ideas. The man who I think knows the woman who lost the dog. That kind of complexity. Sentences within sentences. Before that moment, nothing remotely like it existed. This is the discontinuity hypothesis, and if it's true, language didn't grow. It erupted. The truth likely involves several different pieces coming together at different times. To speak requires a very specific anatomy. For most of evolutionary history, our ancestors didn't have it. The key structure is the larynx, or voice box, and specifically, its position in the throat. In most mammals, including our closest relatives, the chimpanzees, the larynx sits high in the neck. This allows them to breathe and swallow at the same time, reducing the risk of choking. It's practical, but it severely limits the range of sounds they can produce. In humans, the larynx sits much lower. This creates a larger resonant chamber, the pharynx, which allows us to produce the full range of vowels and consonants that make language possible. The trade-off is that we can choke to death. We are the only mammals that regularly die from inhaling food. The evolution of our vocal tract was likely a gradual process over millions of years, with different species in the genus Homo having it to varying degrees. But anatomy is only half the story. What does preserve is bone. Let's go to the Kebara cave in Israel. 1989. Here, a complete hyoid bone was found at a Neanderthal burial site. The hyoid is a small, U-shaped bone in your neck that anchors the muscles used in speech and swallowing. It's the only bone in the human body not articulated to any other bone. When scientists analyzed the 60,000-year-old fossil, they found it was almost identical to a modern human hyoid. This suggested that Neanderthals, our cousins who lived for hundreds of thousands of years across Europe and Asia, may have had the physical capacity for speech. But fossilized bones were just the beginning of the evidence. In 2002, scientists identified a gene called FOXP2. It was immediately dubbed the language gene by the press, a simplification that overlooks its complex role, but the reason it earned the nickname is real. Humans with damaged copies of FOXP2 have severe difficulties with language. They struggle with the fine motor control needed for articulation and have problems with grammar. What made the discovery explosive was this: the human version of FOXP2 is different from the version found in every other mammal, including chimpanzees. The human version has two specific mutations that appear nowhere else. When researchers tested DNA extracted from ancient Neanderthal bones, they found the Neanderthals had the exact same human mutations. This meant that Neanderthals and modern humans shared this genetic adaptation related to speech. Since both lineages split from a common ancestor, at least 400,000 years ago, that version of FOXP2 must have been present in that common ancestor. So by at least 400,000 years ago, our ancestors had the genetic hardware for the physical coordination required for speech. By 60,000 years ago, Neanderthals had the physical throat anatomy that could support complex vocalizations, and sometime before that, the brain had become wired for symbolic language. But none of this tells us what those first words were. The oldest theory is called the bow wow theory. The idea is that the first words were imitations of sounds in the environment. This is called onomatopoeia, and words like crash and buzz are rooted in the sounds they describe. But this can only explain a tiny fraction of vocabulary. You cannot get to words like justice or therefore with onomatopoeia. Then there is the poo-poo theory, which argues that language emerged from involuntary emotional sounds, the ouch of pain, the sigh of relief. While these vocalizations are ancient, they are also largely instinctive, which makes it difficult to see how they evolved into conscious, structured language. There is the yo-he-ho theory, proposing that rhythmic grunts during coordinated physical labor, hauling a heavy log, rowing together, gave rise to the rhythmic patterns that underlie speech. Music and language have tremendous overlap in the brain, and many researchers believe they co-evolved, meaning singing may have come before speaking. Then there's the ta-ta theory, which suggested language began as vocal mimicry of gestures. The broader gesture-first hypothesis is taken much more seriously. The area responsible for language in the modern human brain, Broca's area, is tightly linked with regions that control the fine motor skills of the hands. In non-human primates, that same region appears to be involved in processing hand gestures and facial expressions. The connection is not a coincidence. Pointing is arguably the most fundamental linguistic act. It means, pay attention to that thing over there. And pointing with a finger appears to be unique to humans, and perhaps captive apes. Human infants learn to point before they learn to speak. There is a strong case that language began with the hands, and the voice later caught up. But here's the part that rewrites the story. You can have the right anatomy, you can have the FOXP2 gene, and you can have Broca's area all wired and ready. But none of it matters if you don't have the cognitive infrastructure for what language truly demands: a theory of mind. Theory of mind is the ability to understand that other beings have thoughts, beliefs, and intentions that are different from your own. It is the ability to model another mind. And language, real language, absolutely requires it. When I say a word to you, I am making a sound with the intention that you recognize my intention to communicate a specific meaning. Language is based on a kind of social telepathy. I trust that you can read my mind, and you trust that I want to be understood. The development of this social cognition seems to be tightly linked with a massive increase in group size in our evolutionary history. Managing relationships in larger groups requires keeping track of more people, their alliances, their histories, their trustworthiness. Evolutionary psychologist Robin Dunbar has argued that language evolved precisely as a solution to this social complexity problem. He called it, quote, vocal grooming. Chimpanzees maintain social bonds by literally picking bugs out of each other's fur, which does not scale well when you have 150 people in your tribe. Language lets you bond with multiple people at once. Gossip was, essentially, the killer app of language evolution. Once language existed, the feedback loops became extraordinary. Language allowed for better coordination, which allowed for larger, more complex societies. More complex societies created more information that needed to be transmitted, putting pressure on language to become more precise and powerful. More precise language allowed knowledge to be passed down through generations. And once knowledge could accumulate across time, cultural evolution took off at a pace biological evolution could not match. The moment language crystallized, the game changed forever. Suddenly, humans could cooperate with strangers, plan months in advance, lie, and create myths, stories, gods, and social rules that bound large groups of unrelated individuals into functioning societies. Everything that came after, agriculture, cities, writing, science, this video, traces back to that moment when one human looked at another and said something that they both understood to mean the same thing. We know that by 70 years ago, when modern humans suddenly began creating art, jewelry, complex tools, and trading over vast distances, language was there, fully functional, turning individual minds into a collective project. The behavioral explosion that archaeologists call the Upper Paleolithic Revolution is the visible fingerprint of language. The cave paintings of Chauvet, 36,000 years old, depicting animals with movement, with depth, with narrative. They are the work of minds that had stories. The Venus figurines, scattered across Europe, the carved flutes, made from vulture bones, the careful arrangement of red ochre and seashells, as personal adornment. These are all the products of a species that had learned to make things that existed in the mind exist in the world. That is what language does, it externalizes thought. Every language on Earth today, all 7,000 of them, shares deep structural properties that linguists believe are hardwired into the human brain. Noam Chomsky called it universal grammar, the idea that all human languages are fundamentally the same language in different clothes, because they all emerge from the same underlying cognitive architecture. Babies in every culture acquire language in the same way, at the same pace, through the same stages. A baby in Tokyo, and a baby in Lagos, and a baby in Sao Paulo will all babble, then produce single words, then two-word combinations, then full sentences on a roughly identical timeline, without anyone explicitly teaching them the rules of grammar. The capacity is installed by evolution. Here's where I leave you. Language was not a biological inevitability, it was a social solution. It wasn't just the product of a bigger brain, but the catalyst that drove the brain's expansion. It emerged from a long series of anatomical adaptations and genetic mutations, but it was ignited by the simple need to keep track of who was doing what with whom around an increasingly complicated campfire. That pressure, the need to manage our social world, was the moment words became more valuable than silence, setting the stage for everything that followed.